we're going to host a webinar on analytics engines. What do we mean with an analytics engine, by the way, is anything that will give you insights from data, right? We're going to discuss a bit more about what it is exactly. Maybe first, let's introduce ourselves. So I'm Chris Peters. I'm the founder and CEO of DataMinded. And next to me is Kai. Maybe Kai, you can also introduce yourself.
Yeah, so my name is Kai Zhang. I'm a senior data engineer at DataMinded, and hosting this webinar together with Chris.
Yeah, exactly. So who is DataMinded? Probably most of you have heard of us already, but we're a consultancy and we build data products, data platforms, data solutions, data architectures, those kind of things for companies, typically here in and around Belgium. And that's what we typically do. We're also very active in the cloud. We're big cloud promoters where we try to partner with all three clouds, all three big clouds like Amazon, Google, and Microsoft, because we believe all three of them have valid offerings to do data and analytics. We're not a big fan of doing on-premise deployments. We try to avoid them as much as possible. We're also partnering with all of these three providers. So we're an Amazon Advanced partner, we're Microsoft Gold partner, and we're also a Google partner. One more thing to note about DataMinded is that we recently launched Datafy, and that is a tool that helps you accelerate data product development. So it helps data teams to build, deploy, and govern data products using a code-first approach. That's not the main topic of today. The main topic is the analytics engines, but at the end of the webinar, we'll see how we try to apply our own lessons learned in Datafy. So let's dive into the actual content of what are the analytics engines that you actually need. Maybe Kai, something that you want to take over from here?
Yeah. So typically there are so many technologies, and I guess everyone has their own preferences for which technology to choose. For example, some people prefer R, some people prefer TensorFlow, some people prefer just doing everything in Excel. Like what we want to do here is just set which are the pros and cons of every analytics engine. There's no extremes that should be there. So it's not that because you like to do everything in Excel that everything should be in Excel, or it's not because that you do everything in R that everything should be in R. We're not here to discuss that, but we do want to highlight that there are some pros and cons, and you want to weigh everything a little bit before choosing your analytics engine.
Would you like to have the mouse too? Yeah, that's easiest maybe. Yeah.
And so let's dive immediately into the.
Why is this? Sorry, you pressed one button. Sorry, guys. Yeah, there we go. Yeah.
So let's dive immediately into the key messages that we want to deliver today. And there are actually three main things that we want to discuss. The first one before is you should always look at the problem first. Don't get carried away by CV-driven development. Just because there's a new technology and you want to have that on your CV, it doesn't mean that you should adopt that technology for your projects, right? Like always look at the problem. What does the business want to achieve? And that should be the focus of choosing your analytics engine stack. So focus on the business need first. The second thing is look at the team, right? Because you could have a small team, you could have a big team, you could have a very mature team, you could have a very just started out team. Also look at the composition of your team. Do you have a lot of data analysts? Do you have a lot of data engineers? Do you have a lot of data scientists? This is also going to define how you should choose your analytics engines. And then finally, when you've looked at those two, then we're ready to look at the engine itself, because that comes only after those two. And some key messages that we want to deliver there is connect over polarizing. And that's something we're going to discuss in more detail. Like we want to bring things together and not just choose one thing only because that's just what you prefer. Like, for example, doing everything in TensorFlow because that's just what you prefer. No, let's just look at how we can connect things. We prefer to have simple over complex. That you can start out with simple iterations, like start with something basic that works. And once you get that better, you can always go to more complex things, right? And when choosing technologies, also, we prefer to have technologies that have a broad community support over things that are super niche and super hard to find people.
Exactly. All right. So maybe, I'm going to take that mouse thing here. It's a bit weird. So this is the executive summary. Now let's dive into each of these things. So first, let's look at the problem. So in the end, I think it's important to distinguish here between what we call insight creators and insight consumers. So what do we mean with an insight creator? That's your data scientist, that's your data engineer, or your data analyst. That's anybody who takes data, does something with it, and creates an insight, right? And then on the other side, you have insight consumers. That might be business users that look at the Tableau dashboards that you created. There might be downstream applications that get fed by your data pipeline, or there might be end customers who benefit from the insights that you create. The focus of this webinar is on the insight creators, right? So the people who use data to create some insight. And in the end, that formula is very simple. You have data, you have some kind of algorithm, and that results in an insight. So what is an algorithm then exactly? Well, it can be anything from just data integration, combining data sources together, aggregation, machine learning, can be super advanced graph analytics, NLP, whatever you want to do. In the end, it's just you apply an algorithm to data and you get some kind of insight. Now, if that is the entire scope of your world, like this is the only thing you need to do, then we can stop the webinar here, because you can just choose whatever tool that you prefer to write your algorithm in and be done with it. But in reality, what we see at organizations that we work with is that if you want to create insights at scale, you need to probably create more than just one algorithm, and you need to create several what we call data products. What is a data product? Well, imagine you have some data sources on the left, and you want to create some insights on the right, and you want to make those insights available through a dashboard or through an API or through a data, whichever tool you like, doesn't really matter, but you want to create some insights. Well, typically, this is not just one big single monolithic step you do in the middle. No, typically you build several so-called data products, maybe one data product that extracts data from a source, makes it available in a data lake or something, and then a product that is built on that product that creates a particular insights. And you chain those products together into large data platforms, so large data analytics environments. So that's one key message. Like, okay, if we need to look at the business problem, it's not just writing one particular algorithm. No, it's looking at the entire system and how that works end to end, right? So always start with the business problem. Always look at what do we need to solve before you look into. I've seen a new cool technology on whatever, on YouTube or on Hacker News or wherever that you see. No, first look at the business problem. So let's take an example of customer churn. You could say, hey, I want to predict customer churn. I'm going to do scikit-learn or whatever. Well, actually, you could also look at it in iterations. So maybe if you want to build a data product that creates business impact, maybe the V1 of the data product would just be some exploratory data analysis, maybe just using Excel, and then at least you can quantify the current churn that a company has. And only just quantifying the current churn, that already provides a lot of insights for a lot of our organizations. Once you know that, you can move to a V2, where maybe you build a dashboard that updates the churn per region, per segment, per category, or whatever. And this would allow all salespeople to understand churn across different dimensions, right? So based on this understanding, they can approach the customer differently, or they can position the products differently, something like that. We didn't even look at machine learning up until this point. This was just descriptive analytics. And then finally, once you really understand that as well, then you can look at churn prediction algorithms and actually prevent churn with tailored offerings or whatever. So the message here, the first message of today we want to bring, if you have to choose an analytics engine, first look at the business problem. Don't get carried away by CV-driven development. Instead, focus on the business need.
Yeah, exactly. So coming by that first message, the second thing you want to look at is who is actually in your team, right? Like, you can't deliver things that are just impossible. So typically when delivering data analytics projects, you're going to have 3 typical profiles. And what I'm going to do is I'm going to depict them very, very extreme right now. Like, usually it's not the case like that, but yeah, you can see that these roles exist. So let's try to depict them a little bit. So you have the data analyst. The data analyst, typically what he wants is he wants to be close to the business as possible, as close. Typically he's going to be solving business problems and going to focus on delivering insights to the business. And what is he looking for? Well, he's looking for quick iterations, right? Like if the business problem pops up, he wants to get that question answered as fast as possible. Ideally, present his insights through visual insights, for example, in PowerPoint or even in a dashboard or a report. And the ways he gets to this is typically by doing joins, aggregations, mappings, sorts, filters, and all those kind of operations. And then if that isn't enough, like typically people are going to have data scientists who are much more comfortable, closer to algorithms, and who actually have that expertise to focus on models. And they have also a more academic approach to things to actually come with more cutting edge solutions. What they're really going to look for is experimentation, try different models, try different features, try to see if they can get some additional insight. They usually make use of algorithm libraries. I'm sure most of you will know a lot of those libraries. We're going to discuss them also a little bit. And typically they want to go from local computation also to more horizontal scaling afterwards, doing things more in the cloud in order to have that computation more at scale. And that's where data engineer comes in, right? So data engineers are closer to data pipelines. Typically, they are software experts, not always, but typically. And they have more focus on the technologies themselves, right? Like using different programming languages and so on. So what they're looking for is they're going to use different language stacks, typically Python, Spark, Scala, some use Java, and so on. And they're going to have to make sure that the data products that you build are going to be reliable at scale and in production systems.
Yep.
They're going to be doing the data heavy lifting, typically. But that's also kind of stereotypical what I just depicted, right? So the goal is actually to bring those roles together in a cross-functional team where they move closer to each other. And it's not so that, oh no, that's the algorithm, so only the data scientist should touch that, or that's Excel, like the data engineer doesn't want to touch that, or that's programming, that's code, a data analyst doesn't want to touch that. Like we try to overcome these stereotypes, have them working together more closely, and trying to have them use each other's tools also a little bit more to understand each other. So the message we want to bring is, if you have these different type of people in your team, then you should try to combat the weaknesses that these people have and focus on the strengths that they have. And what I mean with that is, let's say like you don't have the ideal scenario always, right? Typically, you're going to have something more than something else. For example, a team has a lot of data engineers and a lot of data scientists, but is rather low on analysts. Well, in that situation, what you might do is try to push self-service analytics more, try to put data analytics products more in place so that business can actually self-serve themselves and try to create dashboards on top themselves that they can create easily. And what you have to do to achieve that is try to automate your flows so that you get there, and that the last mile is just
exactly
more or less self-service.
Absolutely, right? Yeah.
In the case where you have data engineers and data analysts, but you're quite low on scientists, something what you could do is actually go for AutoML. That is a library that exists on AWS, on GCP, Azure. There are also open source libraries. And what it does is you have a typical data science workflow, and it tries to automate that to get a first prototype as fast as possible that delivers value and that immediately sets a baseline.
It's never going to be as good as if your data scientist builds the model,
exactly.
But sometimes it's good enough, right?
It's good enough to start with, for sure. And if that's the case, and you don't really focus on use cases without AI, why not?
Yeah,
that's a good approach to go with. And if your team is low on engineers, then I guess it's better to go with off-the-shelf technology solutions. As we also discussed in the previous webinar, there exists a lot of off-the-shelf technology things, more software as a service components, which you could easily pick. And in that case, I'd suggest to focus more on delivering insights through a POC mode and focus a little bit less on putting into production.
Yeah.
So the message that we want to give here is try to overcome these stereotypes, have everyone collaborating more closely together, try to create a cross-functional team. But that's not always going to be the case. So in that situation, try to focus on the strengths that you have and try to combat the weaknesses that the team has.
Yeah, exactly. So now we're at the third part of the actual engines. Now look at the actual engines themselves. So if we plot this diagram again of a data analyst, a data scientist, and data engineer, we put them back at their extremes. Like, remember, it should be the case that you work more closely together. But if you look into the extremes, what do we see typically in clients that we work with? This is definitely not a 100% complete picture, but this is the reality we often see, is that if you look at the extremes, like a data analyst, he or she will be most comfortable in reporting tools. A data engineer, they are focused on building pipelines that can be batch or streaming. And a data scientist is very often focused on research tools, where because he's so close to the algorithms, the research tools help him the most. Now, there are also tools that bridge the gap between those profiles. So if you look, for instance, if you want to bridge the gap between an analyst and an engineer, there's a whole suite of ETL tools where, let's say, less tech-savvy people and data engineers can build data pipelines. There are some restrictions there, but it lowers the barrier of entry a lot to build data pipelines. So that is definitely one of a trend that we see a lot. On the other side of the spectrum, if you want to bridge the gap between an analyst and a scientist, we see a lot of these so-called visual analytics tools where you might not be like research-minded enough to really build your own algorithms, but you can apply machine learning algorithms in those visual analytics tools. And even as an analyst, you get some insights, you get some predictions done. And then finally, what we often see the gap being bridged between data scientists and data engineers, this is in the typical ML libraries, right? So a data scientist has built a model. Now that model has to be operated, has to be deployed, has to run every time, has to be part of your operational data pipeline. And then there's a whole suite of machine learning libraries that help you with that. And then finally, at the very center of this all is a lot of these tools are based on programming languages. Now, you don't typically directly use the programming language itself. You use one of these tools that are based on the programming languages, but still it's very valuable to understand the programming language that goes on behind the scenes. So if we map a few example technologies on each of these on this stack, it's what you see on the reporting tool side. You see things like Excel and Redash and Tableau. It's all familiar to most of you probably. If you look at what a data engineer, the kind of tooling that they are mostly working with is tools like Spark or Kafka Streams or Apache Beam, or there's some other like very data engineering heavy tools, right? That might be that another profile works with that, but this is really typically what you see a data engineer work with. And then a data scientist, they like, well, they're research heavy tools like R or MATLAB or things like that. Then if you look at the tools that cross the boundaries a bit, the visual analytics tools, some popular there are NIME, Alteryx, and SPSS. On the ETL side, you have the traditional ETL tools like Pento and Talent. There's also a tool called DBT. It's relatively new, but definitely check it out because we like it a lot. We use it at some of our clients, and it follows engineering best practices while still making it easy for analysts to build pipeline using plain SQL, actually. So it's a really nice tool. And then on the machine learning side, Kai already mentioned AutoML. You have Spark machine learning, you have TensorFlow. There's a million libraries out there. Like I'm sure, like you have something in your head, like an analytics engine that's not on here. We didn't try to be complete, but this is to give you a rough sense of where we are. And then in terms of the actual pure programming languages that we see a lot coming back, it's SQL. We see a lot of SQL. We see a lot of Scala, or maybe more Java-based, like Java is just a big ecosystem, and then Python-based. Now, maybe one thing that we might offend half of the audience here is saying that Python is a programming language and R is a research tool. It's not that black and white, right? Obviously, R is also a programming language. MATLAB is also a programming language. But what we see is people who use R, that is almost exclusively data scientists, right? You probably have a use case in your organization and say, no, our data engineers build their data pipelines with R, but I would call that the exception, right? It's the same that there might be an exception where there's a data analyst that built all their insight with Kafka Streams, but most data analysts we know that actually built their insights with Tableau and Excel and stuff like that, right? So in 90% of cases, this is what we see in organizations. And this is also the trade-off you have to make when you pick a tool. Don't just look at the tool itself and all the features, but look at for which profile or which target audience is served for this tool, and what can you do with it, right? Now we're going to go step by step into each of these areas and look at the pros and cons of each.
Yeah, so let's start off with visual analytics. As you can see on the diagram on the right, this is somewhere used mostly between data analysts and data scientists. It's not black and white, as Chris also already mentioned. But we're going to just discuss it as we see as because it's usually used between analysts and scientists. So when should you use visual analytics? Well, it gives you a nice visual representation of your whole analytical process, right? So that's quite nice to have. It's usually used in combination with other analytics, such as ML and such. And when you don't have that much data engineers, it kind of really makes sense to use such a tool, because you can do the whole flow from end to end actually with a visual analytical tool such as Alteryx, 9, and SPSS, as some companies use. So that immediately also brings me to the pros and cons. The pro is it's a drag and drop tool, right? Like you can visually easily see everything from end to end. But at the same time, that's also a con. You're often restricted because it's a drag and drop tool. Like if the vendor only supports that, then that's the only thing that's supported. The good thing as well is that having these automation things, it enables self-service, right? Because business analysts are easier going to be able to do things themselves, and that's what we mean with self-service. And another good thing is you're going to be doing the whole flow. You're going to be doing cleaning in it. You're going to do ingestions in it. You're going to do even a little bit of exploratory data analysis with it. So those are all pretty good pros of using a visual analytics tool. The con on the other side, as I already mentioned, is the flexibility restriction that you have, because you're not using code. You can't go as flexible with it as, for example, compared to Python or R. And then you have a little bit of vendor lock-in.
Yeah, exactly.
And the research tool, as also Quinten Rosel asked in the chat, well, research tools, what we mean by that is tools that are mostly used by data scientists, like usually in an academic context or in an R&D setting, and typically used for cutting-edge scientific research and even creating new algorithms and testing them on, for example, custom solutions that are not existing in R and Python. For example, creating a solution to recognize cancer cells based on impedance measurements. These are the only things that you can do with research tools, I think. So that brings me to the pros of using research tools. Like most engineers and scientists that graduate, they already know that interface. It's a quite easy to understand syntax. They know the interface quite well. It's easy for them to experiment and prototype with it. And they offer a lot of abstraction and libraries already available to iterate on. So that makes the iteration cycle a lot shorter. On the other hand, there are also some cons, of course. If you're out of the academic context, I don't see a lot of companies with Maple or MATLAB commercial licenses available. These tools also tend to focus more on numerical calculations, especially in MATLAB, as compared to speed. And yeah, it doesn't incorporate the software development lifecycle, right?
Yeah, we had a few cases at clients that they really insisted on putting their MATLAB algorithms live, and it's not just running the algorithm, but it's running the entire MATLAB server as part of your data pipelines. It was really not a pleasant experience, right? So these are, as Kai said, very good for research, but once you want to industrialize, they often have their limitations.
Exactly. Yeah. And that brings me to ML libraries. Typically, you see that more between data scientists and data engineers working together. And that's typically once you want to industrialize certain data science projects. Simple counts or simple group bys and joins don't help anymore. Like you want to find those deeper insights, then for sure use ML libraries for that. The pros to that is it's quite fast. I wouldn't say easy, but you can get started quite fast. Like there are a lot of tutorials available. There's a lot of support and community for using ML libraries, so that's a really good thing. It's also flexible and customizable, and like you can open pull requests, right? Like you can customize things. It integrates quite well if you're using a programming language. And it has even the most cutting edge deep learning libraries available, things such as in TensorFlow. Like, yeah, nowadays it comes so quick. Like cutting edge research is available at your doors, just like that. But there are some cons also, because like tuning ML is something different as just using an ML library, right? Like it needs experience, like deep business knowledge, and it requires quite some math and statistic knowledge in order to use them quite properly, and in order to have some advantage. Like everyone can just type in some commands, but if you don't know what you're doing, like chances are low that it's gonna provide any business value there. Another disadvantage is like ML libraries are quite resource intensive and expensive in general, like as compared to other things. And like if you're using ML libraries and you want to bring that to production through a pipeline, like you're gonna have to incorporate software engineering best practices, and you're gonna have to incorporate some general guidance and governance on that.
Yeah, absolutely. Yeah. All right. Let's move on. We're now at the bottom right of our little diagram here. Like this is the typical pure data engineering tools, where they're used obviously for most data heavy lifting, right? In the end, as a data engineer, your job is often there to enable data analysts and data scientists to do their work. You don't create a lot of insights yourself, but you enable them to create the insights. So you make sure that you connect all the data that's available in a format that they can parse. If you look at the real-time streaming pipelines, where a trend we see a lot is that companies want to start building event-driven architectures where everything that happens in their organization is being put on a message bus or something and is being processed in real time. So there's a real cool use cases of data processing. The pros of that is that it's very powerful, very scalable, very flexible. Like if you work with these tools, you can do a lot of heavy lifting. It's really fun. Especially for the real-time tools, your time to insight is very short, where some other tools, it takes you days to compute something. Here is like, bam, you get it instantly. It's really nice. What's also really good is it's the software approach to data, right? There was BI and analytics before the data engineers showed up. Well, what the data engineers bring to the scene is the software methodology. And we know like software is eating the world. Well, software is also eating the data department more and more, we think. The cons of this is that, if we're really honest, like it's hard to get adoption, right? When I look back at data mining, when we started 6 years ago, we really came from this angle. I was like, yeah, you need to do Spark and you need to do data pipelines and everything as code, and push that very hard. But in reality, there's just not a lot of software engineers active in data. So it's hard to get a lot of people building Kafka streams pipelines or anything, right? So the learning curve of these tools is quite high, especially if you don't have a software background. And also it comes with a lot of distributed system complexity. And how do we see that in reality as well? Is that these event-driven architectures, for instance, when you talk with senior architects, they always have a great vision of how an event-driven architecture in a company would look like, and they're always 100% right. It's not the slides, like the architecture is always perfect, but executing and building like a event-driven architecture across an organization, it's really hard, right? Don't underestimate the software engineering complexity that comes with it. And be honest, like with your, like, did come back to team skills, like be honest, like, is this something that my team can carry, yes or no, right? And that's a question that you can answer, like, but it depends. It really depends on your team. Finally, we move to the ETL tools. I think those are quite well known. So ETL stands for extract, transform, load. And it's really good to, if you have structured data, and transform that in some kind of way. If you want to build data warehouses, if you want to do daily batch calculations, then it's really powerful to do that. Pros, again, is often drag and drop like the visual analytics tool, so it's easy to get started. And you can mold the data in any way you like, so it's really nice. The cons, again, is because many of these are drag and drop. If you do this at any kind of scale, it's hard to keep track of versioning, testing, deployments. All of these things become more difficult. Most of these tools don't have any advanced algorithms. It's really like joins and sums and aggregates. They don't have any like linear regression or something. And they all struggle with big data, right? If you have high velocity data, high volume data, high variety data, that's not where these ETL tools shine. So super useful tools, choose them where they are fit for purpose, right? And then the reporting tools, well, we all know these kind of tools like Tableau and Excel. This is to communicate insights with business. They're very good for data exploration. They're also very good for insights adoption. And what do I mean by that? Like if you can convince your entire organization to look at Tableau dashboards every day, to see what the status of your organization, of your operations, of your sales, like based on that knowledge, they can make better decisions. So if you want to have insights adoption, like definitely a data analyst is the first one to deliver that for you using these kind of reporting tools. The pros is a very low barrier of entry, and one picture says more than 1,000 words. So it's better to see one bar chart than to look at 100 data tables. The cons, and it's sometimes people forget, but many of these tools, they're like what I call dead-end streets in analytics. What I mean by that is if you build some kind of insight in Tableau and then make a visualization on it, that insight is typically not pushed back to the data warehouse or to the data lake. That only lives in Tableau, right? So it's kind of a dead-end street there. And it's also limited in power. Like you can't do any big data processing with these tools, obviously. Yeah, and then finally, also the programming languages themselves, they're a little direct use, right? I don't know any organization who just said we're going to do only SQL to build everything or only Python to do everything. But we do see a lot of the frameworks around these libraries, around these languages that are being adopted, and those frameworks we just discussed. And a good understanding of these languages, that really helps you in using the tools that are available for you. So if it doesn't hurt if you know a bit of Scala or Java, it doesn't hurt if you know a bit of SQL or a bit of Python, right? So always good to have in your arsenal. So if we zoom out again, we dived into each of these tools. So there's analytics engines for each profile in your data team. You have on the extremes, you have the reporting tools, the research tools, and like the pure data pipelining tools. And there's also tools that are more cross-functional that more people in your team can use, like ETL tools and visual analytics tools and ML libraries. At the core of a lot of these tools is our pure programming languages, right? So how do you choose an analytics engine now? Knowing what the business objective is, knowing what your team is, knowing, okay, I understand which tools are out there. A few recommendations we can make here is that always look for tools that are connecting. So select an engine that is supported by your entire team and allows them to collaborate. That's always better than so-called polarizing engines where every team member in your team says, I really like this tool and I'm going to build my data product in this tool. That seems that seems nice, like, hey, we're agile and we're enabling people to do their own analytics. What you end up with after 2 years is having 100 tools in your stack, and that's unmaintainable, right? You cannot choose one tool for the entire organization. That's also bullshit. But you cannot just let every engineer or every scientist choose their own tool, because that becomes really unmaintainable. Next is always go for simple over complex. So if you have a tool that serves the business need, that are easy to work with, easy to maintain, and easy to operationalize, that's always preferred over complex tools with large learning curves, complex to deploy, etc. Now, of course, it's important that the tool actually serves the business need, right? If you want to do a real-time predictions of something, it's not good enough to come up with Alteryx or something, right? You need something that can handle real-time data. And then finally, definitely also look for tools with broad community support, like ideally open sourced, actively maintained. They evolve over time. They're easy to find help. Like Stack Overflow is full with questions of those things. While if you compare that to the niche tools that are typically shipped by large organizations and they only work in their own tech stack, like typically you buy a database and it comes with stored procedures and you do all your analytics in the stored procedures. Well, that creates a lot of lock-in into that specific database, right? Because now all of a sudden, if you want to move databases, you also have to rewrite all your analytics. Another trait of these things is that they slowly evolve over time or not at all. So definitely try to avoid these niche tools.
Yeah, so to come back to the executive summary that we started our presentation with. So first, look at the problem. Don't get carried away with CV-driven development and focus what the business actually needs. And if it's just a couple of joins and just a count, then that it is, right? Exactly. Look at the team, overcome the stereotype, try to work together, create cross-functional teams, which focus on the strengths that the team has and try to overcome the weaknesses. And then finally, once you looked at those two, then you look at the engine. And as Chris just explained, like we try to connect the team more, over polarizing that only one person likes to work with and the rest doesn't. Try to have simple over complex. You can always iterate on that. Like it can become more complex after time, right?
Yeah, exactly.
And then finally to have a broad community over niche.
Exactly.
Voilà.
And so as a last word, how do we apply this at Datafy? So what I told earlier, when we started Data-Minded, we were very opinionated about these are good engines and these are bad engines. Like, oh, don't use this, do use this. Like we got over ourselves, so to speak. Like like it's just reality that people will prefer their own engines as long as they nicely work together. And what we do see as a common baseline is we say, hey, if you have a code-first approach, so no drag-and-drop tools, if you want to do everything in code, if you want to collaborate over code, then Datafy might be a solution for you. Again, Datafy is there to accelerate data product development. What would that look like in practice? So imagine you have a data pipeline that looks a bit like this, where you create several data products, some of them using R, some of them using DBT, some of them using Python, and so forth. Well, actually, what Datafy does is that we're going to put all of these data products in a Docker container. And I'm oversimplifying here, but in the end, we will ship the Docker container to a Kubernetes cluster. And this is also something, by the way, that you can perfectly do on yourself. And we see a lot of organizations moving to containerization to standardize. The complexity with this is like doing all of these steps requires a lot of DevOps knowledge, requires a lot of infrastructure maintenance. And that is not something that adds a lot of value to the business. So what we say there is like, you build the tools and the technologies that you like the best. You do it in a way you like the best. It's all like whatever you like, as long as you can wrap it in a Docker container, we will make sure we deploy it. We will make sure we monitor it. If it goes down, you'll get alerting. If the Kubernetes cluster is not big enough, it will scale. We'll manage that for you, so that you can focus on actually building the data products and not get lost in the data platform or in the all the technology stacks that come behind that. Normally, I would have done a demo, but I actually prefer to have some interactive discussion and questions. And I see we have like 15 minutes left, so let's switch to questions. Are there any questions from the audience?
We've had one already answered.
Okay. I'll stop sharing and go back to the screen here. Feel free to unmute yourself if you have a question. Maybe people don't dare to ask a question now, they're a bit nervous.
I have a question.
Yeah, go for it, Bert.
Okay, how do you choose whether you stick with open source tools or cloud vendor native tools?
That's a very good question. What we said in the broad community support always, like my first reaction is always goes for open source first. But a lot of these cloud native versions, they are backed by open source projects. Like take Google Dataflow, for example. It is backed by Apache Beam. So in the end, you just write Apache Beam pipelines. But let's be honest with yourselves. I really do not know a lot of organizations who write things in Google Dataflow and then deploy it open source somewhere. So as much as possible, I would go for the open source, but then find a managed way of running that. So another example maybe is you have AWS Kinesis now supports to run Apache Flink. You also have Kinesis Analytics, but that is very proprietary to Kinesis. Well, I would prefer to write Apache Flink and then deploy it to Kinesis, right? And let they take care of the run for it. But I would first look at the engine and then only look at the deployment option. Does that make sense?
Yeah, that makes sense.
Cool. Other questions or things that were not clear? Nobody got offended by. Yeah, go ahead.
I was just curious whether you would put Power BI and ClickSense as tools on the different accesses.
Yeah.
These are tools that we typically also see, well, label as reporting. I know they do a lot more than reporting, but I would call it a reporting tool because in the end, it's about sharing the insights that you created with business. I know a lot of these tools, by the way, Power BI and Tableau as well, they can also do some embedded ML, right? You can do some sentiment analysis right in Tableau, but typically I would put them in the top spectrum. They're very close to analysts. So I don't know a lot of data engineers or data scientists who work directly in these tools.
And that's what they're still the best at core, right?
Exactly.
Chris?
Yeah, back Wim. Hi.
Hey, what is how do you see the future? When I look at your diagram, I can see, for example, that Microsoft Azure is doing a big effort in actually combining those three profiles and making sure that those can all work together with the same platform and the same tools. Is it the same that you see with the other cloud vendors, and is that like a good evolution in the market?
That's a very good question. I do see it at other places. I think one other company that is pushing a lot for this, I think, is Databricks. Like they started very much here on the data engineering side with Spark and Spark pipelines. Then they started also serving data scientists with machine learning. And now recently they also doing a lot on SQL, and they bought Redash, right? The reporting tool, they acquired it. So I think Databricks is one of the other companies that tries to bring all of these together in one tool. I am like, as the moment I see the value in that, so that's also what we're advocating. Like, hey, don't be so extreme and come together, work together more closely. But if you put it all in the same tool, what you get is you get a bit for everybody, and not enough for anyone, right? So I don't know how it will evolve. I think more collaboration is always better, but that doesn't mean they all have to use the same tool. That's in the end what I'm saying. So you could perfectly well use different tools, but if you all communicate to the same database, you share the same database, you share the same data workflow management tools, you share the same infrastructure, that's also a way to collaborate, right? You share the same data catalog, that's also a way to collaborate. It doesn't have to be like, okay, we're going to force everybody into the same analytics engine, because that is a bit too limiting for me.
Okay, thanks.
But you do tend to see that with other vendors as well, huh? Like Google, AWS, they're all moving a little bit into each other's spaces. Huh?
Yeah, absolutely. And in the end, that makes sense, right? I recently talked to a business executive, and he was actually frustrated with the fact that these guys are data engineers, and these guys are scientists, and these guys are analysts, and then that's an architect. I don't care. I just need my business problem answered, and I don't want this distinction. So in the end, it's coming closer and closer together. Do I believe we have one tool to rule them all? Definitely not. There will always be a next thing. And every tool will shine in its own area.
Yeah, maybe I have a question. Chris and Kai, thank you. Great presentation. I like the framework. Maybe just for the step one of your executive summary, if you look at the problem, how do you balance a CV-driven development versus the focus on the business needs in engineering heavy or engineering cultured organizations? Do you have some recommendations on that? Because it's always a struggle, I think, with engineering teams, because they want to also learn new things and keep themselves happy on learning new tools. And their primary interest is not always the business needs. So do you have some insights there on how you do that balance?
Yeah, at the very first step, but sometimes you're too late there, but at the very first step is screen your engineers, right? Well, we work a lot with engineers. We are engineers. And when we're hiring, that's actually the first thing we look at. So we have a lot of engineers that come in and want to join Data Minded, and all they talk about is like, I really love Kafka Streams, and I want to do a lot of projects with Kafka Streams. And that's like a no-go immediately. Like, it doesn't matter how good they are. If the only thing you want to do is some kind of technology that looks good on your CV, like, you have the wrong mentality to join Data Minded. And I think, in my opinion, of course, you have the wrong mentality to join any data team, because you should always focus on the business problem. Now, that being said, there's a more subtle answer as well, is from a business point of view, in my experience, as long as you're delivering business value, they do not care whatsoever what you do behind the scenes. So if you replace your Python stack with a Spark stack, or if you replace your Spark stack with an Apache Beam stack, as long as you continuously deliver value and work on your internal work at the same time, and you do them step by step, I believe that works. If you have to go to business and say, hey, we can't do anything new for you in the coming 3 months because we're going to rewrite our entire architecture, that never works. You can never sell that to a team, to a business. So you always have to make sure that they get what they want, so you can focus on what you want. Did that make sense?
No, it makes completely sense. But I also see some cases where the entire stack is written in Java, and I mean, I know a lot of data engineers, and they like Scala much more. So what is then the business value then of writing everything in Java while you have more happy engineers when working with Scala? And so that's like some sort of, it's always a struggle, I find.
Yeah, if your entire team prefers Scala and it's written in Java, then you could, at least you could do the new projects in Scala. But then again, you need to balance that off, right? Because if your entire team likes Scala, then go for it. But be careful that if everybody picks their own pet analytics engine, you will end up with 100 tools, and that is unmaintainable. And we've seen that as well, right? So sometimes it's also, honestly, a bit blunt here, but if you like Scala, but you're complaining that you have to write Java, and that's the biggest worry in your life, I mean, yeah, man, that's life sometimes. Yeah.
And indeed, as Antoine also indicates, you can easily collaborate between Scala and Java development because it's all JVM based.
Yeah, indeed. Yeah. So definitely new development, do it in whatever your team feels most comfortable and most productive in, and that solves the business problem, of course. But you cannot go back to business and say, hey, we need to rewrite 20 data products in Java because now the flavor of the day is Scala, right? You cannot sell that to anyone, right? That doesn't work. Yeah. Was there another question of Flavien?
Yeah, Flavien had another question.
Can you read it?
Thank you guys for the presentation. We are a small team of 3 with various technical backgrounds. We are doing a lot of Spark SQL for our data pipelines to overcome that technical barrier. Would you recommend using dbt in this setup?
From what I read here, I don't know the full context, but from what I read here, definitely yes, like without a doubt. Try it out. It's very easy to get started. We've always pushed back against SQL-based pipelines. We love SQL for analytics. SQL is a structured query language, right? It's not a data transformation language, it's a structured query language. And so we've always pushed back against SQL in data pipelines. Why? Because SQL is a very, like you execute a SQL statement and that's it. It's very monolithic. You get gigantic hundreds of lines long SQL statements to do a transformation. It's very poor to maintain, it's very poor to test. And we were always bitching about it. And while we were bitching about it, a company like dbt said, you know what, we're going to solve this. So they had a much healthier approach than we did. And they allow you to write modular SQL code. They allow you to test. They allow you to easily deploy, test if it works. And again, as you describe your use case there, definitely look at dbt, try it. I think the main difference you'll have to do is, I'm assuming that you run your Spark on a data lake, like on S3 or on Azure Blob Storage or something. Well, dbt typically works on a data warehouse like SQL Server or BigQuery or Redshift or something like that. It can also run on a data lake directly, but it's a bit more complex. So you'll have to migrate your data probably to some kind of SQL store. But I would definitely recommend trying it out. Yes. Yeah.
Thank you, guys.
Other questions?
Okay, I have a question. Thank you, Chris and Kai, for the presentation. So I understand that AutoML is still not the most optimized solution and is not usually visible in the production environment. However, have you already noticed businesses deciding to use AutoML in the production, and how did it go? And also, how do you see the future of AutoML?
Yeah, well, our advice to business there is, if you can get away with AutoML, do it first, right? Like every prediction you have to write it first in AutoML, and if that's sucky, then talk to a data scientist. Even for your data scientists, right? They don't like to write the 80th logistic regression algorithm. Like before there was AutoML, we knew companies who everything they did was always logistic regression. So they build a feature table and then yet another logistic regression model on that. As a data scientist, that becomes very boring as well. You want to focus all of your time on the 2 or 3 very hard data science problems that you cannot solve with AutoML. So I expect more and more adoption to come from AutoML. Yeah. That being said, I tried a few of these myself, and they're not always as user-friendly as they say, right? I use AWS Forecast to do time series predictions, and it's very cumbersome to feed the data to there, and it takes a long time before your model is trained. And then I'm definitely not a good data scientist, but just copy pasting a few lines of TensorFlow code or whatever code, I could get almost as good result myself. So it's not black and white, but I would predict that you would see more and more AutoML pipelines in the future for sure. Yeah.
It also helps you go from end to end way faster. So
yeah,
from collecting the data, setting up the whole pipeline, going to the end, and try to see what the baseline is for that. Like you can always iterate on that and improve it. But I think it helps to go end to end fast and don't get stuck in one stage forever and ever because it was not perfect. Like I think it's better to deliver faster some results to have that as a baseline also. So I think AutoML helps there a lot.
Absolutely.
Great, thanks.
I also have another question, if I may.
Yeah, go for it.
So a lot of companies I see, they start with like these hosted solutions like Datafy and so on. And usually you run into the limits quite quickly. So how do you convince companies to abandon their data factory, set up a cluster, go to the whole GitOps practices while they don't really have the people on board to manage all these things?
Again, a very good question. Assuming you're talking about Azure Data Factory, I think Azure Data Factory is good for ingesting data pipelines because they have a lot of connectors. You can easily connect to a data source, ingest the data, land, and be done with it. What I don't like is Azure Data Factory being used for entire ETL processes or for entire workflow management, or like that's overuse of that tool, I think. I think you kind of answered your own question in the way that if you do not have any engineer or any scientist on your team, well, I mean, there's nothing to migrate to, right? You'll always have to, as much as possible, use Data Factory. But as you say, you quickly run into the limitations of these tools, especially in terms of stability and uptime of your data pipeline. Yeah, what I would recommend is invest over time and incrementally move away. That being said, we're not super successful there either. Sometimes I remember a meeting with an executive where we tried to convince them of a code-first approach, and that executive told me, like, no, we're going to do everything drag and drop, and that's our entire data ecosystem will be drag and drop. I know in the back of my head, like these companies, they will be stuck in the mud for the next 5 to 10 years until they change their mind on this. But then again, I can't say that, right? So it's hard to convince them. Maybe sometimes the tactic I use doesn't always work. We say, hey, look at these modern data companies. Like, look at what Netflix does, or how Twitter deals with their data, or how LinkedIn deals with the data. Like, they don't promote drag and drop tools. They often have a strong data engineering team. They have a strong data science team. Then on the other hand, you're not Google, you're not Twitter, you're not Netflix. So don't try to achieve as much as they try to achieve, but look at least in the direction of where they're going.
Yeah, thanks.
Yeah. Well, there were some more questions on the Slack.
Questions.
It doesn't pop up here on the
Flavian said he couldn't hear you anymore, but that was 5 minutes ago.
Okay.
All right.
Bummer. I see it's 2:00. Are there any other last questions before we wrap up?
Yeah, maybe one more out of interest. What is Datafy doing that, for example, Argo is not doing?
So Argo is a workflow manager and a scheduler. We don't use Argo, by the way, so I'm definitely not an Argo expert. It does one part of what Datafy does. So we also do workflow management. We use Airflow for that, debatable of whether Airflow is the right choice. But Datafy also gives you the environment on which you actually run the analytics. So we will manage the Kubernetes cluster for you. We will auto-scale it for you. We also give you a command line tool where you can quickly build and deploy new analytics projects to production. We give you UI on which you can track, like, what is the state of my data product? Is it healthy? When is it last built? Stuff like that. So we're a bit more end-to-end focused on accelerating data product development. That's what we want to do. And everything that is related to how can we accelerate data product development, that is something we want to support in Datafy. And that's important, without being like, hey, we are the end-to-end platform, and if only everything you do in Datafy, then your whole world will be perfect. No, you do your analytics in your own engines. We just help you deploy it. We just help you monitor it. so that you can focus on the data product and not on all the, let's say, DevOps things behind the scenes.
Oh, cool. Can we try it somewhere? Yes.
Of course, but I'll contact you after the webinar. One last question. If not, thanks all for joining. It was great to see so many people out there. We'll post this on YouTube soon. And then see you in the next webinar. By the way, let me know what you like, what you want to see in the next webinar. And if you're on YouTube, also subscribe to our channel and blah, blah, blah.
And reach out if there are any more questions afterwards or any more discussion points that you want to see answered or discussed.
Absolutely. Thank you very much, guys.
See you guys.
Bye.
Bye.